Oh, hi, algebra students. We are going to be multiplying polynomials today. So I'm going to share my screen and start the presentation. And we're going to start out here with the warm up. So go ahead and pause the video and try this warm up on a piece of paper. All right, let's see how you did here. I'm going to grab my pen. Start this presentation just a sec. Makes it easier for you there. There we go. If it was kind of small for you guys to see. All right, on the first one, we're adding polynomials. This is what we did yesterday. So 3x squared plus negative x squared, 3x squared plus a negative 1 would be 2x squared. Then we have a negative 3x here, a positive 4x, negative 3 plus 4 would give us a positive 1x, and 4 plus negative 8. 4 plus negative 8 is negative 4. All right, on question number 2, use the distributive property to simplify. So I'm multiplying this monomial times this monomial. We have to remember our properties of exponents. So I can multiply 2 times 3 and get 6. But I need to remember that when I multiply by this base of x, I need to add these exponents. And this is a 1. So x to the first times x to the second would be x to the third power. All right, then I'm going to multiply 2x times negative 4x. Positive times negative is negative. 2 times 4 is 8. And x times x is x to the first times x to the first, which would be x to the 1 plus 1, which is 2. And then last, 2x times 5 would be a positive 10x. All right, you might want to review those multiplying multiplying exponent rules, all right, so that you remember when you have the same base, you add the exponents and so forth. That will come in handy in this lesson. All right, we're going to look at multiplying mostly binomials today. So we have what we call the FOIL method, and it's another name for the distributive property, and it comes in really handy when we have binomials like we do in this example. So FOIL, these letters, FOIL stands for first, outside, inside, last. So in this example here, we have 2 binomials. Remember, binomials have 2 terms. The first that we talk about, this f, is where you multiply the first term in this parentheses times the first term in this parentheses. So x times x would be x squared. That's our first. The outer or outside are these extremes. So x times this number way over here, which is 1. X times 1 would be 1x or x. The I stands for inside. It's these ones really close together inside here. So 9 times x would be 9x. And last is the last thing in the first parentheses multiplied by the last thing in the second parentheses. All right, let's look at our next slide. All right, so we're going to use the FOIL method. We're going to jump to some extra practice. The extra practice, this looks like number 1 is on page 212. So if you want to grab your journal, make sure you're there on page 212. So we're going to use the FOIL method. So first we're going to do our first. And our first are the first things in each parentheses first. So x times x is x squared. That's our f. Okay, next is our O, our outside. So this x here times this number way over here. So first outside, x times negative 1 is negative x. Next, we have our inside, our I. That's these 2 terms. Negative 2 times x is negative 2x. And then last, we have the last expression in the first parentheses times the last expression in the second parentheses. And a negative 2 times a negative 1 is a positive 2. Now you'll notice when you do this FOIL method, you're going to have some terms that are like here that you can combine. So I'm going to switch pens here for a second so you can see what I'm talking about. Maybe. These 2 things right here, these are like terms. So I want to make sure I combine those. So this is not completely simplified until I've combined my like terms. So I have x squared. Then I have negative x plus negative 2x is negative 3x plus 2. All right, let's try extra practice problem number 3. All right, again, first, we do our g times our g. G times g is g squared. we do our outside. That's these, right? The far away from each other terms. So g times 4 would be 4g. Notice we don't put the g first, we put the number part first. Then we do inside, 2 times g is 2g. And then last, we have 2 times 4, which is 8. Again, be sure you combine your like terms. This step is super important. So we have g squared, 4g plus 2g is 6g. And then we have a constant of 8. All right, we're jumped to number 5 this time. All right, notice this just had a single x and a single x and a single g and a single g. You can still FOIL even though there may be some number in front of your variable. So again, I'm going to multiply my first terms together. So 3n times n is 3n to the second power. N times n is n to the second. Remember, we add the exponents. Outside, we have 3n times 1 would be a positive 3n. Inside, negative 4 times n is negative 4n. And last, negative 4 times 1 is negative 4. Again, be sure to combine these like terms. So 3n squared, 3n here plus a negative 4n would be negative n. And then we have our constant term of negative 4. All right, we can also use a table to find a product, and some people really like this method, so I want to go ahead and show it to you. This is on page 212. You'll see the little tables. So I'm going to grab my pen here. So to do the table method, you just need to look at each of these binomials. It doesn't matter which one you pick to put in vertically or horizontally. And then we're going to use, and some of you have done these like Punnett squares in your science classes. It's the same kind of idea. So I'm going to put my y here and my positive 1. I'm going to put a y here. And I got to be careful. This negative goes with the 6. Notice this was a positive 1, so I didn't worry about putting the 1 there. All right. So now what I'm going to do, I'm going to grab a different color here for a minute. I need to do these little, it's like doing a multiplication table if you think about it. When I do y here times y here, I have y times y, which is y to the second. Then I'm going to do this first row times the second column. So y times negative 6 here would be negative 6y. All right, and I'm going to do this row times this column. 1 times y is y. And last, I have 1 and times negative 6 is a negative 6. Now you'll notice these terms here on this diagonal are like terms. So I can write down my y squared from here. I have my negative y, or excuse me, my y plus my negative 6y is negative 5y. And then I have my negative 6, right? So some of you may want to try that. You might find that easier. Let's look at another example. This time I have 2w and a negative 5 in my first parentheses. And I have a w and a negative 3 in my second parentheses. All right. Let's switch up my color here again. So I'm going to do 2w times w. So this first row times this first column, 2w times w would be 2w to the second power. First row times second column would be 2w times negative 3. 2 times negative 3 is negative 6w. All right, I'm moving on to the second row. Second row times first column, negative 5 times w is negative 5w. And last, negative 5 times negative 3 is a positive 15, and negative times negative is positive. Again, notice the terms on this angle, this diagonal. Okay, those are your like terms. So my final expression is 2w squared. I have a negative 5w plus a negative 6w is negative 11w. And my constant term is a positive, and don't forget your sign here, it's a positive 15 that I need to write down. All right, now we can also have multiplying not just binomials by binomials, but we can multiply a binomial times a trinomial or two trinomials. All right, so this is extra practice number 19. You can either do this with the distributive property where you're going to multiply x times x squared, x times x, and x times -1, and then distribute the -2. -2 times x squared, -2 times x, and -2 times -1. I think that gets kind of messy. So what I like to do is I like to do it with like regular multiplication. So I'm going to put my, what I call my bigger number on top, my x squared plus x minus 1. I'm going to put my trinomial on top and my binomial right underneath it. And now I'm going to use regular old multiplication, like the multiplication algorithm you used in elementary school. I start over here in the ones place, right? In this case, in the constant place, and I multiply. So I go -2 times -1 is a +2. And I'm going to remember to put my sign in there, right? Because he said +2, and I know this is going to be a string of monomials. So I'm going to make sure I have that. Then I move, so this is just like regular multiplication. -2 times 1, -1 is +2. Then -2 times x, -2x. Then I multiply my -2 times my x squared, -2x squared. All right, what's the next step in the multiplication algorithm? We move over to the tens place or to this column, right? If you want to fill in your 0, you can, right? Doesn't hurt anything. I just like to shift over. So now I go to this place, x times -1 is -1x. X times x is a +x squared. And then x times x to the second power would be x to the third. All right, your last step when you're multiplying like a 3-digit number times a 2-digit number is to add, right? We look at these columns and we add. So I'm going to bring down my +2. I have -2x and -x is -3x. And in this column, -2x squared plus x squared is -x squared. In here, I bring down my x cubed. Right? So again, you could get there by distributing. It's just when you distribute it, you'll have this really long string of terms that you will need to combine. So you might want to try both methods. Let's even try a different one on 24. And maybe you can decide which method you like better. So I'm going to try it with the distributive property method this time. So everything in this first parentheses needs to be multiplied by everything in the second parentheses, right? It's like a big distributive property problem. So I'm going to go 2p squared times 3p. That's 6p to the third power. Then I do 2p squared times my -1, -2p squared. All right, I've taken care of the 2p squared term. Now I need to, I'm going to switch colors here again. Now I need to multiply the p times everything in the second parentheses. So I have p times 3p is a +3p squared. I have p times -1 is -p. All right, that green is super hard to read, so I'm going to switch it up here and let's grab blue. Right? Last, I have this -3, and I'm going to put the little loops down here this time. So -3 times 3p would be -9p. And -3 times -1 is a +3. So notice you're not done here, right? On this one, after we did the multiplying, we just added and our like terms were already aligned. But this time I'm going to have to make sure that I combine all my like terms. All right, so I look around here. I've got a 6p cubed. Are there any more cube terms? Nope, I bring it down. All right, now I'm going to look to the squared. -2p squared plus 3p squared would be a +p squared. All right, then I have p minus 9p. That would be -10p. And then I have my +3, right? So you guys are welcome to try either method when multiplying trinomials times binomials. See which one you prefer. All right, your assignment today is in the book. It's on page 369. Please do problems 3 to 15 odd, 20 to 24, 29, 31, 35, and 37. The link to the textbook pages is on Schoology. If you have any questions, you can email me. Good luck, and I'll see you next time.